One very useful thing you can do with a Jupyter notebook is bring in external data that you can then manipulate, analyze, work with inside the notebook. In this sense, it's kind of replacing Excel like we typically use in a freshman physics lab or a high school physics lab. You probably have the students store them in a spreadsheet like Excel and then do some stats work on it, get some averages, standard deviation, get a trend line, etc. And that's all well and good. Like we've been using spreadsheets to do that for a while now, but once you get that data imported into Python, all of the tools that are available in Python are now available with whatever data it is that you're working with. The biggest challenge is, well, how do I get my data in there? Because obviously I don't want to sit and type the data line by line into Python if I've already got it recorded in a spreadsheet. So let's walk through how you would do this. So this worksheet here just walks you through this process, has you import a sample data set and graph it, not working with it too terribly much. The goal here is just to get a spreadsheet and Python to talk to each other. So the first thing we're going to need to do is import a couple of libraries. We're going to be using the pandas library. This is, if it's not already the de facto library for this, it's quickly becoming the de facto library for importing data and working with data sets in Python. It's used in a lot of data science practices and programs, so we're touching up on data science here just a little bit. And then we're going to import the matplotlib Python module that we've used a few times on this channel, but we'll review how we do that here. So the first thing we're going to do is run the cell. If you're new to Jupyter Notebooks, there are text cells and there are code cells. The text cells just kind of walk you through what you're going to be seeing. It's basically a documentation. Think of it like a lab report. And then the code cells is where we put in the Python code, and we can click a run button here, the play button here, to have it run the code that's inside the cells. So the first thing it's going to do is going to take the pandas library and import that and give it the nickname PD. So all of these Python libraries have sort of a standard shorthand that you use to reference the library. You can call this whatever you want. It's just that if you call it anything other than PD and then hand it to somebody else, they're not going to know what it is because it's not the standard. And then it prints imported pandas to tell us that it successfully completed line 1, and then we'll ask it to import matplotlib.pyplot as PLT. Right, this would be really long to write out every time, so we just say PLT as the plotting library that I want to use, and then again it prints that it imported these things. So anytime you're reading a Python code, the computer's going to go through it line by line in order. So it goes line 1, then 2, then 3, then 4, etc. Let's see here. The next thing we're going to do is talk about how to get the data in from a spreadsheet. So the best way I know to do this is to upload your data to Google Sheets. Because we're working in an online environment here in Google Colab, it kind of makes sense to post this to a Google Sheets. I'm sure there's ways to get it from an Excel file if you're running this natively, but most of the time you're probably going to be running this in a web browser anyway with an internet connection, so it's probably just as easy to pull it from a Google Sheet. And then it doesn't matter where you run this, you have access to that same file. So Google Sheets works exactly like Excel, 99.9% exactly like Excel, I should say. There are columns, there are rows. This is data I pulled in from a pendulum experiment where I was using, I think it was Firefox, to measure the acceleration my phone felt as it was swinging along in a pendulum motion. So this is the acceleration this way, so it's the centripetal acceleration. It doesn't give you the acceleration this way because the phone was spinning this way, so that complicates matters. But the only acceleration this way was the centripetal acceleration, so we're measuring that versus time as the pendulum swung back and forth. Obviously, there's lots of data here if it's collecting it every few seconds, it looks like. So I've got 133 data points here. So what you do, if you've already got this data in Excel, there's a couple ways you can do this. You can either create a new Google Sheets, and they have a shortcut for that, sheets.new, that will automatically, at least in a Chrome browser, I don't know whether it works in another browser, that will automatically create a new spreadsheet for you. You can then copy and paste your data in from Excel, and it just works the exact same way. Or you can go to File, Import, and then import a spreadsheet. Like you can click Upload here, select a file from your device. You can then bring in an Excel file, a .xlsx file, or even a .csv file, and it will open it here in the spreadsheet for you. Then you need to set the sharing permissions so that your Jupyter Notebook can find your Excel document, or excuse me, your Google Sheet. It looks a lot like Excel. There's a couple ways to do that. The simplest way is to just go to Share and change this option down here so that anyone on the internet with this link can view. So you click on change this to anyone with the link can view, and then copy the link. If you are working with some sensitive data and you need to only share it with your Jupyter Notebook and you don't want anybody else to stumble upon this or to hack their way into this, there's other options for doing that, but I recommend looking up how to do that. It's a lot more complicated, requires bringing in more functions and more libraries. It's more complicated than I want my students to have to worry about. So since we're just working with, some motion data, either from their phone or from some lab equipment, I'm not too worried about privacy there. So anyway, you go and you copy this link, and then what you're going to do is paste that link into here. Now there's going to be a little bit of a difference here. So you notice that we've got the same link here that I just pasted. It's got the same little code here. Each Google Sheet is identified by this unique code. It's just some alphanumeric gibberish that's generated whenever you create your Google Sheet. But what you want to do, this last part where it's got /edit and then possibly some trailing stuff, you want to change that into export. So you can either just paste the URL itself and then change that to export, or the other way you can do it, go into your URL up here in the search bar and just grab that code, right? You don't need the docs.google.com part. You don't need the /edit. What really makes your Google Sheet unique is this code address here. So you go and copy that. You can then go over the key, the tag, the code that I have here, right click and, it doesn't have that there. Edit, paste. There we go. And I obviously didn't change mine because that I've already referencing that, but all you do is change that key to match the key of the spreadsheet that you're working in. So let's run this. What this is going to do is ask pandas, right? So it's asking PD here to read something in from Excel. It's saying, hello pandas, I have an Excel document that I need to read in and I need to work with as a database. So what this read_Excel function is going to do, it's going to take the spreadsheet that it finds there at this URL, and it's going to turn that into a pandas database. Now, a pandas database is a special type of object in Python. It's going to record all that data and what the headers are and anything we need about the data it's going to include in the database. It tells me it's finished reading. Great. So let's try out accessing some information from the database. Anytime you use the term database, you're referring to the entire thing, the entire block of data. So like if I run this where I have print database, it prints the entire thing. And this is kind of handy because I probably want to check to make sure that I imported the right spreadsheet. So I can look here and I can say, well, this is time, this is AY. Up here I have time and AY. My time start in the 17,000s because it's reading off some clock that the cell phone has. So the 17,000 the actual value doesn't matter. It's the change that matters. And I can see here that I've got those values progressing here. I've got my AY values. It looks like they match. So it looks like I'm in pretty good shape there. I'm starting to wonder if this is actually in seconds or if this is in milliseconds. I'll have to go back and check my Firefox setting. It's possible I have the wrong units later on. But anyway, you can then get more specific information. Like let's suppose you only want the time column. So you could put in an open bracket here, an open quotation mark, and then ask for time. Now it's only going to print the time values. You notice it's only time, it doesn't have the AY. Same thing here, I can go and type in AY. And this is going to work for any columns that you have, right? Maybe you've got an AX, AY, and AZ, or maybe you've got time, angle, angular velocity, angular acceleration, that type of thing. You know, depending on whatever your lab equipment is outputting, you can reference that name. Now, it doesn't know how to grab names that aren't there. Like if I ask for, show me the database column that's called Brian, I get barked at with some error messages. But what I look at is I see key error Brian, and I say, oh yeah, I never created a column named Brian here. And so I would just change that back to the thing that I actually want. Another thing you can do if you want to reference specific items here, let's try AY of 0 here. So notice I've got two square brackets here. I've got one for AY and one for 0. What does the 0 mean? Well, it means it's going to go for that top line. What you might have noticed when we brought this up just as AY is that it gives you a row number and then the value. So it's telling me I've got row 0, row 1, row 2, row 3, row 4, etc., etc. What makes Python a little bit different is that it starts counting at 0. And I forget this all the time. Just watch my channel. You'll find me forgetting that Python starts at 0. There's mechanical reasons for this, that it turns out that computers function much more efficiently if you start counting at 0 than if you start counting at 1. It's just a thing you get used to. It's not a thing you get to change. It's one of those things that when our students go and have their career, they just have to get used to that Python starts counting at 0. And there's memes and jokes about this online. And once you kind of wrestle with it, you get to be part of that club where you get to laugh at those jokes. So when you say AY of 0, you're saying I want to access this first value that ends in 70120. And sure enough, there it is, 7012. It omitted the O this time. It's just not showing as many significant digits. You could go anywhere in the list you wanted to. You could go to element 5. So that should be the 6th one. Should end in an 0742. So let's go to 1 or 0, 1, 2, 3, 4, 5, 0742. Sure enough, it worked out. But wait, there's more. What if you want to get a subset of the items? What if you want to get the first 6? You could type in 0:5, and what the colon means is I want you to display more everything from 0 to 5. Click run. Sure enough, you go 0. Actually, excuse me. Another joke is that it never includes the last one. So it goes up to, but including that last one. So if you wanted 0 to 5, you would put in 0:6. This actually works the same way as it does in a spreadsheet, because like if you do the summation function, or not summation, let's try average. Let's suppose you wanted the average of all the AY values. You could put average of B2 colon, how far does this thing go down? It's like 130 something, colon 133. Just B133. There we go. You're probably familiar with using this to calculate averages and standard deviations. It works the exact same way. The colon just means go from here to here. The only difference, like I misremembered, is that in a spreadsheet, it counts that last one. In Python, it doesn't include the last one. But what that means is if you wanted the whole thing, you could ask for the length of database. And length of database always goes to the end because it's accessing how long the database is, which is kind of cool. And there's some more options here for you to try out. If you want to open this Jupyter notebook, you can certainly give all of those options there a try. But that's just printing. That's just displaying what we already have in the spreadsheet. You're wondering, Brian, why is this advantageous? Well, let's talk about how you might make a graph of these things. So if you're just looking to graph one data set, then you can use the database's built-in plot function, right? So you can say database.plot. Now what the dot means is that you're going from an object to its attribute. You're saying here is the object database, this big, ethereal thing out there in Python that stores all this information. Well, that database has attached to it a plot command. It's saying, I want you to plot something from the database. Okay, how do you want me to plot it? Well, I want you to make a scatter plot. So the scatter is attached to plot. The plot is attached to database. Think of these dots as being like a possessive. I want to take the database's plot, and I want the plot's format to be scatter, right? And then what you can put in is the two things you want graphed. There's literally only two things here, time and AY, but imagine you have more columns, and then you need to specify which things you're plotting. Well, this is going to put time on the horizontal axis and AY on the vertical axis. And so that alone, if I get rid of all the rest, let's suppose I comment all the rest out with a control slash. These hash marks mean it's a comment. Please ignore the rest that's coming. That will just get you this, right? So that'll get you some labels, AY and time. It'll get you your scatter plot. It'll get you the axis markings. It's not doing any of the rest of the stuff just yet, but it's at least getting you that information. So with one command, you can have Python do what it takes you many, many clicks to do in a spreadsheet, right? If I wanted to graph this in the spreadsheet, I've got to do, let's count the clicks. 1, 2, 3, 4, 5. Give me the wrong kind of chart. Where is a scatter plot? 6. There we go. So that took me 6 clicks just to get it displayed, and then I've got to go, and I don't know why it's leveling out at 0 up here, right? I would have to go in and fix things in that display. Whereas in Python, you just copy paste this from a previous example, click run, and you get your graph, right? So once you have this written, you don't rewrite it. You just copy paste it from one example to the next. But let's suppose I wanted to include my units. And let's suppose I'm correct about the seconds here. I'm going to have to check that in a little bit. I can uncomment those. This is saying, hey, plot command, right? Remember we defined PLT based on the pyplot library about 10 minutes ago. We said matplotlib.pyplot as PLT. Well, I want to access PLT's xlabel command to change the label on the x-axis and the ylabel command to change the label on the y-axis. And lo and behold, I get the information there I was looking for. Now, how did I know to use xlabel and how did I know to use ylabel? I Googled it because I don't remember whether it's xlabel or ylabel or horizontal label or horizontal title or whatever. I just go to Google and I say matplotlib change axis label. I put in the thing that I want, and then I get here, the very first example gives it to me as xlabel and ylabel, or I can go into the formal documentation and learn more about it. But the important thing is I learned that I need to use the key term xlabel and ylabel, and that will change those there. Now, let's suppose I'm not interested in all of this data, right? Because there's something weird going on here at the beginning or it's just starting out. I'm really interested in this part. Let's suppose I wanted to change the x bounds, right? I can do that using the xlim function. If I click play here, that's going to change my x limits to be this range, to go from 18,200 to 19,500. I think I want a little bit longer than that, so let's take this out. You just kind of keep playing around with this till it gives you the thing that you want. Let's start at 18,000. Did I say 100 earlier? I certainly meant 1,000. And we'll go out to, let's go out to 19,000, let's say 700. I'm just guesstimating my numbers there until I get the values that I want. And yeah, I think that's a pretty good range. It gets me 2 complete cycles from trough to trough, trough to trough there. You could also change the x limits if you wanted to, like maybe you only want to go up to -10. Uncomment that. Right, that's going to cut off there. Obviously, I'm not seeing that as well, so I think I want this to be just like this, right? So you kind of keep adjusting those numbers till you get the graph that you want. And once you have it, it's all saved there in the Jupyter Notebook. So when, like if you're using this in your class and your students submit the Jupyter Notebook, you just have to run it and you'll be able to see the stuff that they made exactly like they made it, right? There's a section here about, manipulating some more of the graph elements. I'll let you open this notebook and work through that. But that's basically what we do with this. We use this to import data. We use it to create graphs of the data. And what we'll take a look at next time, what is the next one? We'll take a look at how we go and manipulate that data so that we have an idea of what's the power that Python here offers you over using a spreadsheet.